Okay, anyway, let's go a little bit back and refresh what we discussed. One important thing that we discussed about yeah, identifying the problem. When there is an issue, what you should do first, right? So, first thing, focus about the LEDs. If LEDs are okay, then you can continue with the switch configuration. That means all the indicators are green, right? If there is any other cases, then there is a problem with the hardware part, right? There is a problem with the hardware. That means particular cables are not properly connected, or there can be any issues which can be indicated through the LEDs, right? So let's help you to uniquely identify the segment of the issue. That means what port there is issue, maybe port 10, right? Whether the redundant power supply is off, right? Then make sure that it is up and serving. So once you are address those things indicated by LED, then every LED will work in green mode. So then you can continue with the switch configuration. So once you enter the switch configurations, commands are there. Then for those commands, you use accordingly to make the correction with the configurations, right? If you want to remove the VLAN and introduce new VLAN, there is a particular way, right? Remove first it by using the no VLAN command, then start it or create it again using the VLAN command or assigning an IP address. There are different things. Then once configurations are done properly, then again look into the physical link connection. So it should be addressed at the early stage as well. Here, by looking at the LEDs, you have to make sure that all LEDs are working. I think this is stage. What CDP stand for? I'm not sure about that. Check with CDP. Fix any cabling problem. Anyway, it is focusing about what are the cabling problem as required, because sometime what do you think? This stage it should be corrected through the LEDs, but here also there is another stage that they specified. Anyway, there is no harm to look into the link connectivities. So not sure about this, what CDP is. Shall I check? Yeah, Cisco Discovery Protocol, CDP. Right? Check with the Cisco Discovery Protocol, fix any cabling problem. So I think Cisco Discovery Protocol, you are not explicitly running. I have never explicitly used that one, but understand is a discovery protocol that runs over the layer 2 on all Cisco manufacturing devices and allow network management application to discover Cisco devices that are neighbors of already known devices. With CDP, network management application can learn the device type, simple network management protocol agent address the neighboring devices running lower layer transparent protocols. This feature enable application to send SNMP queries neighboring devices. So that means it is automatically functioning CDP thing. That means to assure the neighboring device which are in the layer 2 level. So that will indicate something for you. Based on that, connect make sure the connectivity is appeared. So this is focusing about the LEDs and find out the fault with the connectivity. This is focusing about the CDP and find out the connectivities. So basically I have not used that CDP, but I think we are implicitly using that without noticing. But next time just focus it and do that, then you will be noticing it when we do the practical, right? So L2 path between the switches, okay. Then VLAN configurations are okay. So after that, everything is settled. So these things are there actually for the beginners, but I think you follow all these steps when you find the problem implicitly, right? Without focusing, you are just using. Then we'll move forward with the topic that we have to cover today. Preventing broadcast storms. Preventing broadcast storms. So, what is your present understanding about the broadcast? How broadcast domains are introduced?
255.
Huh?
IP 255.
Yeah. When you want to introduce the broadcast traffic, destination IP is the last IP address. So how we introduce the broadcast domain? That means you have better understand about the broadcast domain beforehand. There are two domains, no? Collision and broadcast domain. So broadcast domain is applicable for what? What is the scope of the broadcast domain? Broadcast domain එක කියලා මොකක්ද area එක අඳුරගන්නේ අපි? It's the network, right? It is the network. So I hope you can remember difference between the collision domain and broadcast domain. Collision domain is applicable at the layer 2 level. So collision domains are limit at the port of the switch or layer 2 level. Collision level boundary is the port of the switch at the layer 2 level. Broadcast domain boundary is the network device, layer 3 device, router, right? So boundary for the broadcast domain is the interface of the router. So that means one particular network is in the one broadcast domain. So we are going to prevent broadcast storms, right? Broadcast storms mean when we introduce the broadcast traffic, it may keep repeating everywhere, then it introduces the unnecessary administration traffic over the network, right? I think you have that understand about the broadcast and broadcast storming, right? Keep repeating the keep repeating the packets, then it eventually introduces the unnecessary traffic. So we want to prevent that, right? Let's look into that, how to address that part. Broadcast system occur when a large number of broadcast packets are received on a port. When large number of packets are received on a port. So actually large number of broadcast packets, right? Forwarding, I think you get the idea, right? That means large number of broadcast traffic introduced by the different devices. Uh, so eventually the um, unnecessary broadcast packets are loaded into the port. Right? Forwarding these packets can cause the network to slow down or to time out. Obviously, administration traffic proportionately increased with that. User traffic එකට වැඩි වෙන administration traffic එකේ වගේ situation එකේ. So that is the focus in the second point. Then third point, storm control is configured. Storm control is configured for the switch as a whole. Storm control is configured for the switch as a whole, but operates on a per port basis. Right? So here it is about how to control the storm. It says the configured for the switches. So extra switch configuration is there, but operate on the per port basis. We'll go forward and try to understand what is happening. Storm control is disabled by default. Right? By default, storm control is default, but you can enable it and configure it for the switch as a whole, but operate on the per port basis. In this case, actually, I'm just thinking the layer 3 feature should be comprises, no, to touch with the broadcast storm. So I think this is only about the VLAN capable switch, which has some layer 3 functionalities. Let's move forward and see. Prevention of broadcast systems by setting threshold values to high or low, discard excess broadcast. Okay, that means broadcast systems are accepting, but there is a threshold. Maximum this number of or 100 number of frames within a second. That might be the threshold, higher value. Right? Logic is not applicable in this case, right? We want to prevent the higher threshold is the part applicable with the excessive broadcast. Multicast, unicast, whatever the those kind of traffic, right? So in addition, configuration of values for rising thresholds on a switch will shut the port down. So once it is increase in the threshold or go beyond the threshold, then definitely the port is shut down to avoid or to due to the higher workload, right? So you see, I think this is the way that we already discussed with the spanning tree protocol. So that part is again appearing under the preventing broadcast system as uh, yeah. So preventing broadcast systems uh, again handled by the spanning tree protocol. Spanning tree protocol problem includes the broadcast systems, loops, drop BPDU, and packets. Right. So as you're already aware about that, we will move forward. You know how to pick the root bridge, location of the root bridge in the extended router and switch is necessary for effective troubleshooting. So anyway, once the root bridge is in the center, so whatever the management stuff become much more convenient. So that is the point raised in the first. Switch is necessary for effective troubleshooting. So right, it focus about the first thing is location of the root bridge in the extended router. Extended router. Usually we are talking about this spanning tree protocol at the layer 2 level. Here it is talking about the router. Yeah, this part is clear about the root bridge. Then I move forward. It says locate the root bridge in the extended router and switch is necessary for effective troubleshooting. Yeah, switch is necessary for effective troubleshooting and the whatever the root bridge switch should be located maybe centralized place. Involvement of the router. This is little bit questionable because we are not discussing about the involvement of the router with the use of the spanning tree or layer 2. Yeah, I will check it that, right? Right. So we'll move forward with the next one. Show commands on both the router and the switch can display root bridge information. So it is obvious. You know how to use the show commands to find out that root bridge and the others those are labeled as designated, right? Root and designated. So show what is the command to display the this one, show spanning tree. Show spanning tree describe all the things that we already discussed. So you know how to do the manual configuration. That means setting the priority of actually not fully manual. Setting the priorities and then tree will be deviated from the original tree because at the moment all the switches having the same level of priority, so they use the MAC address for finding out the root bridge. So what you're doing, you just assign the higher value for lower value to assign the better priority. අඩු level එකක් දුන්නොත් අපිට priority එක වැඩි වෙන්නේ නේ. Then eventually the span entry will be stabilized as you require. However, here the focus is introducing the manual configuration. It becomes necessary because it is possible to reduce the BPDU traffic. So manual configuration approach is also there. As per this statement, however, I have just enabled the span entry protocol and allowing or changing the priorities of the switch. That only we have done. So having idea that even manual configuration is there to reduce the BPDUs. In our case, automatically generating the span entry takes some time to learn themselves each other and finalize with the tree, even in the simulation environment with the limited number of intermediate devices. So the things will be much more complex actual environment with the multiple switches. In that case, actually, sometimes that might be the practice with the use of the manual configuration. So you have to use a manual configuration in such situation to avoid the extra traffic. So you can, I think, manual configuration with the manual configuration, the one some extra step of configurations are the ideas. Let's go forward and see, right? First thing is the setting the time on the root bridge at their maximum level. So once you set the timer, then it generate BPDU, maybe 1 second time at every time, then or 2 second times. So depending on the requirement, you pick the whatever the appropriate timer for the particular environment. So it generates the BPDUs accordingly. If you put the timer very short, the number of BPDUs are generating is very frequent. If you just optimize time or set the timer little large, then what will be happen? Number of BPDUs generating is little low, relatively low. So specifically set the forward delay parameter to the maximum 30 seconds. So lifetime of the BPDU and the max age parameter to the maximum of 40 seconds. Forward delay is 30 seconds, maximum age 40 seconds. I think those are belongs to the manual configurations. Physical port on the router or switch may be part of more than one span entry if it is a trunk. Yeah, physical port of the router is there because even router is a layer 3 device. Eventually it has the layer 2. Layer 2 involvement is there in the router. So that one also take part of the spanning tree, right? So I think, yeah, that part is extended router. Sometimes it is referring to the our gateway. For the network, there is a gateway or connecting to the router at the one end. So that end, we can find all the 3 layers: data link layer, physical layer, data link layer, and the network layer. So that network and data link layer involvement is important for establishing this spanning tree. Eventually, the broadcast systems will be reduced. So whatever the router interface is applicable, so here we can put the actually once it is important, that means once the at the end the tree is introduced, right? At the end tree is introduced. So from where that root of the tree starts, that is the question here. So here in the first statement it says the root start from the interface of the router, right? Interface of the router, location of the root bridge in the extended router. That means uh, router is not necessary to establish the network, but router allow internetwork communication. So in that case, router involvement is important. At the same time, the interface of the router we can introduce as the root bridge, right? So I think that part is emphasized here. Mm, hope you understood that. Right? That means spanning tree one. It just recommend to use the router interface uh, as a root bridge because of the layer 2 involvement. Right? So yep. Physical port on a router or switch may part of more than one spanning tree if it is a trunk. Yes, this thing happen. That means switch related. These two things happen actually. Both things happen. That means in the one physical network, with the initiative of the VLAN, we can find many logical network. So things are applied in the VLANs. Logical network mean VLANs. There are multiple VLANs in the one physical network, which is ended by the one single router interface. Within that, maybe let's say 3 VLANs, VLAN 10, 20, 30. So VLAN 10 also used in the router interface port. VLAN 20 is also used in the router interface port. And VLAN 30 also used in the router interface port. So all 3 VLANs are used in the same port, right? Then link from switch to router. Just visualize the situation. Link from switch to router. Also, there is a link from the switch to router. Then focus about the switch end of the that link. Then you can realize that switch port end comprises with all VLAN related contribution. Because it is a trunk. Simply it is a trunk, right? That port hearing or accepting traffic with related to all the VLANs. Otherwise, trunk cannot be formed now. So in such situation, even that port represents the more than one spanning tree. more than one spanning tree set වෙන්නේ අර VLAN concept එකත් එක්ක. ඉස්සෙල්ලා physical network එකක් ඇඳලා ඒක උඩ VLAN network කොහොමද link වෙන්නේ මොකද කොහොමද port use කරන්න කියලා ඇඳලා බලුවොත් trunk කියන ports තියෙන links trunk port contribute වෙන links repeatedly use වෙනවා multiple VLANs වලින්. ඒ කියන්නේ ඒ branch ඒක එක VLAN එකක් ගැන එකපාරක් හිතුවොත් ඒකට ඒ trunk port එකට අදාළ link එක තියෙන link එක නැතුව මුකුත් කරන්න බෑ. It is compulsory to have that link. VLAN 20 ගැන හිතුවොත් that particular shared link is required. Trunk. Then VLAN 30 හිතුවොත් ඒක essential. Then what is the conclusion? That trunk is connected with the two ports at the two end. Trunk කියන්නේ cable එකක්ම තමයි. ඒ cable එක port එකකට දෙපැත්ත connect වෙලා තියෙනවා. එහෙනම් ඒ port දෙකට මොකද වෙලා තියෙන්නේ? ඒ port දෙක spanning tree එකට multiple spanning tree වලට contribute කරනවා. They are contributing for the multiple spanning tree. So VTP runs on catalyst switches, not the router. That is also important. So VTP, VLAN trunking protocol, trunking port is there at the switch end. In the route end, it is handling at the different level, but that particular port is still accepting the layer 3 traffic. Sorry, yeah, I would say that a router interface related port is always accepting the multiple VLAN related traffic. That is the point here, focusing. Anyway, the concept that the router it uses is not the trunk. Right? Trunk port එක switch එකේ තිබ්බට router එකේ තියෙන ඇත්තටම trunk එක නෙමෙයි. මොකද router කියන්නේ layer 3 device එකනේ layer 2 වලදී තමයි අපි trunk කතා කරන්නේ. Trunk port, trunk කතා කරන්නේ layer 2 වල. දැන් switch දෙකක් link වෙලා තියෙනවා නම් ඒ switch දෙකක් link වෙලා තියෙනවා නම් එකට ඒ particular link එක VLAN multiple VLAN related traffic කරන් යනවා නම් අන්න ඒක trunk එකක් කියනවා. නමුත් switch එකයි router එකයි connect වෙලා තියෙදි multiple VLAN related traffic කරන් යනවා. නමුත් router end එකේ trunking concept එක නෙමෙයි තියෙන්නේ කියන එක තමයි emphasize කරන්නේ. I also just forget that. However, that concept logically you can think and understand because VLAN trunking protocol applicable at the layer 2 level. So in the router interface, layer 2 is there. Router interface, the layer 2 is there, but it is not only rely on the VTP. There are concepts to somehow differentiate the traffic it receives with related to the multiple VLAN. I think we are discussing those stuff in the next lecture, VTP. So by that point, we will just understand about that, right? So it is advisable to configure the catalyst switch neighboring a router to operate in the VTP transparent mode until Cisco supports VTP on its routers. Yeah. It is advisable to configure catalyst switch neighboring router to operate in the VTP transparent mode until yeah, whatever the VTP thing we will discuss in the next session because it is anyway try to establish the VTP connection with the router. Here it says it is advisable to configure catalyst switch neighboring a router to operate in the VTP transparent mode. So eventually layer 2 level of the router as per this one assisting for the VTP communication. But there is a conflict with this statement, not here. VTP runs on the catalyst switch, not the router. Okay, then VTP runs in the catalyst switch. That means, yeah, Vlan trunking protocol. That protocol runs in the and get the contribution from the router interface. It seems, although the whatever the operation part, eventually the router involvement is there, no layer 2 involvement of the router. That thing is facilitated by the router, but the VTP main operation, main activities happening at the switch end as per the present understand. But with that understand, we will move forward and finalize those stuff at the next session, right? With the VTP. Because I also cannot remember that part as we are not doing a VTP related specific configuration on a regular basis. Uh, anyway, move forward and see. So spanning tree protocol is considered one of the most important layer 2 protocol on the catalyst switch. Yes, true. Preventing logical loops is also true. Minimize spanning tree problem by actively developing baseline study of the network. Minimize the spanning tree problems by actively developing the baseline study of the network. So baseline study means the actual network requirement. We set the max time, min time, max age, right? As we discussed previously. So eventually, whatever the problem is related to the introducing the spanning tree can be addressed. Our spanning tree එක automatically configure කරලා අතන manual කතාව කිව්වේ ඒක තමයි. Yeah. With this manual configuration, yeah, this one. Manually configuring a device as a root bridge in another configuration option. Yeah, with that manual configuration, whatever the root bridge related details are configured manually. That means to optimize the spanning tree protocol stabilization. You can spanning tree protocol එක stabilize වෙන්න මොන හරි operational or administration traffic එකක් යනවා නම් ඒක අපිට ඕන විදියට arrange කරගන්නවා. So that part is discussed here. So maximum threshold, maximum age, timer, those things are manually configured, like setting priorities. Even that part is included there. So here it says minimizing spanning tree problems, right? So we can minimize the spanning tree problem even though spanning tree is a recommended way to prevent the broadcast storm. It also introduced some sort of unnecessary traffic to stabilize the network, or some other problems are there. So with that one, baseline study of the network, that means what is the actual purpose of the network. With that thing, how frequent we have to introduce the BPDUs, likewise specific details, specific information to have the improved network, we configured manually, right? Even configuring priorities or setting the priorities are very much good improvement, because based on the MAC addresses, right, at the very beginning, every switch has the same priority, right? Every switch has the same priority. Then MAC address is used to find out the root bridge. So it is very much ineffective. So what you are doing the manual configuration. and assign the best possible lowest numeric number, then eventually that will be picked as a root. So obviously that switch is in the middle of the network, allowing to communicate with the devices, other devices, very convenient manner. If it is sitting at the edge of the entire network, so distance to the fine device is high. ඈතින් තියෙන device එකට දුරයි. මැදින් තිබ්බොත් ඔක්කොමලටම ළඟයි. Just simply introduce a network similar to the star topology. Right? So such manual configurations are there. Yeah, that is about the preventing broadcast systems. Eventually, actually, we discussed the span entry involvement with that preventing broadcast system stuff. So, which is our lecture 3. Default values for the hello time, forward delay, maximum age. These are the timers incorporate with the span entry protocol. So you adjust the timers to optimize the stabilization, or as per the requirement of the network, you optimize those timers. Basically, if you don't want to introduce the BPDUs, every 2 seconds, if you want, you can keep it as 2 seconds. If you don't want, you make it 4 seconds. So BPDUs are generated every 4 second time. So whatever that segment related administration traffic will be reduced by 50% definitely, because the time is double. Such initiatives are there to improve the performance of the span entry protocol stabilization, or introducing the logical topology on top of the physical topology. So it is a tree. Logical topology is a tree. So it will not introduce the broadcast systems, right? It will not introduce the broadcast systems whatsoever, because it is a tree. No loops are there. So yeah, here we discuss about the router involvement. With that one, I think you somewhat understood, but next lecture we will finalize with those concepts with the VTP. Anyway, at some point it says as the starting point of the network is the interface of the router. So introducing it as a root, introducing it as root is also possible, but finding or listening to the other criterions can be, depending on the network design, it can be varied. However, VTP configuration is available at the catalyst switch in router. Use it transparent mode of the VTP. That means whatever the VLAN creation, all the things are happening at the catalyst switch. I hope you can remember that transparent mode. What are 3 modes? Client mode, server mode, no? Client mode and server mode. So once the router to operate in the VTP transparent mode, it means the particular port, if we want to introduce the VLANs in that port, we should do that port itself. So that thing will not be shared with the switch, right? VLAN creation with the VLAN VTP server switch. We create in the VLAN in the VTP servers, then that thing will be shared with the others. VTP client switches, we are not even configuring the VLANs. We just accept in the VLAN created in the VTP server switches. So VTP transparent mode where router is also in. So if you want to create the VLAN, there the router interface even that part we have to do make but make sure that it is in the transparent mode. So in the troubleshooting, for that there are some specific commands. Show, debug commands are extremely useful. Yeah, next we looked into that. It illustrates the problems. Common problem in troubleshooting the VLAN. Yeah, trunk ends in the different VLANs. That means you have not configured the trunk properly. Different end of the trunk is specified different VLANs. For example, VLAN 1, 2, 3 are enabled on the one end but not at the other end. Right? One end VLAN 1, 2, 3 is there, then it is not there. Maybe 1, 2 only might be there but not the 3. Then VLAN 3 might not allow to communicate. So the protocol single different end of the single VLAN link specify the different VLANs when the switches are not multi-VLAN capable and when not running the trunking encapsulation protocol. Yeah, that means switches support for the only one VLAN, not supporting for the multiple VLAN, but you try to configure it for the multiple VLAN, right? Likewise, there are different problems. Just go through for some understand, but those are some common, right? But there are some unique aspects as well. So you will learn those throughout your hands-on experience. So to troubleshoot the operation of the fast Ethernet router connections to switches, it is necessary to make sure that the router interface configuration is complete and correct. It is necessary to make sure that router interface configuration complete and correct. So because if we are not sure about the router interface is correct, we cannot make any correction at the switch end because we are not sure about the other end. So one end should be correct first. So if you are focusing about the VLAN level, so layer 2 level, then if it is the other end is the layer 3 level router interface, we have to make sure that that end is configured and configured correctly and work properly, right? So it is obvious or common thing. Verify that IP address is not configured on the fast Ethernet interface. Verify that IP address is not configured on the fast Ethernet interface. It means that means we are going to configure the troubleshoot the fast Ethernet connection to the switch, right? Your focus is here. Fast Ethernet router connection to switch. Then it says verify that an IP address is not configured on the fast Ethernet interface. IP address is not configured on the fast Ethernet interface. I think it is obviously it should be the router interface. Okay. It is all about interface and sub-interface once I look into this one, because with the VLAN configuration, VLAN environment, we usually use the one particular interface of the router to facilitate multiple VLAN. So we are moving forward with the sub-interfaces. One router interface is divided into many. One router interface is divided into many and shared with the different VLAN. So sub-interface of everything. So router interface, if there are VLAN 10, 20, 30, router interface is divided into 3 sub-interfaces. So in that case, once we divide one interface into 3, the one main interface is not configured with the IP address. Right? IP address is not configured because it is going to be divided. Router interface is going to be divided into 3. Right? Router interface is going to be divided to facilitate the multiple VLAN. Right? Router interface is going to divide to facilitate multiple VLAN. In that sense, that main interface is not configured. Right? Only sub interfaces are configured. That is the understand here. So if in case if it is configured, it means there is a problem. So I think there is a lab sheet for that. So with that one you can understand properly. So verify that duplex configuration on the router matches that on the appropriate port interface of the switch. So duplex mode. So both then whatever the configuration should be matching. Right? So show VLAN command display the VLAN informations. So you just look into that and verify that it has been configured appropriately to cater your requirement. So whatever the information it display VLAN ID, name, status, assign ports, those things you can find it. Here is an example with those initiative VLAN number, name, whether it is active or not. Not sure about the index anyway. Ports are also not yet assigned for the VLAN. It is simple. Sorry. Default VLAN first interface 1 to 2, 2 to 29. Yeah, actually range of the ports are specified.
Ports.
Yeah, ports numbers are specified 2/4 to 5. That means in our case we use the 1/ something. No, default interface got 0. I cannot exactly remember. This is the way specifying the port as a range 1/1-2. That means first interface card port 1 to 2 is in the default VLAN. Second interface card port 9 to 29 in the first VLAN 1. Even 31 to 34 also in the VLAN 1. But VLAN 100 represent the second interface card port 4 to 5. Second interface, port 6 to 7 interface, port 30. Those are the so those are important to find out the or troubleshoot the network accordingly. So Catalyst OS keyword syntax descriptions. So any device has some sort of operating system, otherwise it is just a hardware. Then with the operating system, actually we introduce it operating system on top of that small firmware is there, right? So not fully hardware control device. CatOS shows Vlan keyword, show Vlan keyword options and keyword syntax description of the each field are also shown. So there are show VLAN, you can put the options trunk. Or different things are there, right? So at this stage, just have some idea about having these different keywords. When you come to actual use, just focus and do that. Many of them actually not commonly used, but if index description is here, na? If index interface index assigned by simple network management protocol. SNMP is running now. With that one, for interfaces to it's simple network management protocol assign numbers to maybe prioritize different VLANs, right? Management purpose, they just give the number interface index. In our previous if index was there, can you remember this part? If index, this is assigned by the SNMP, right? So there are many more. There are many more. So look into them and try to understand. Some are common, some are not frequently used. Okay, just give me a second. Uruttaransa is calling. I will answer that and come back within 2 minutes. When having difficulty with the trunk connection between the switch and router, be sure to consider the following possible causes. So such scenario can be happen due to many things, right? So few causes are discussed here. The link in between the switch and router we introduced through the sub interfaces, but we would not be able to successfully implement it. So due to some reasons. So one of them, make sure that the port is connected or not received any physical layer alignment or frame check sequence errors. Right? Make sure that port is connected and not receiving any physical layer alignments or frame check sequence errors. This can be done with the show interface command on the understand that part. That means whatever the connectivities, whether they are connected properly, first thing. Then alignment or frame check sequence error. So that thing is not common. Anyway, such a criterion is also there to analyze for cause. Right? Eventually, the show interface command will assist you on that. I think, yes, that understand enough at this stage. We'll move forward. Then verify that the duplex and speed are set properly between the switch and the router. Yeah, this is like a compatibility with the two ends. What is the duplex mode and what is the speed set at the two ends? If these two things are not synchronized, the communication is not continuing in the smooth manner. This can be done with the slow. This can be also done with the show interface status command on the switch or the show interface command on the router. So looked into that, then you can find the duplex and speed values. So both ends, that thing should be same. Then third thing, configure the physical router interface with one sub interface for each VLAN that will route traffic. Yeah, we looked into that in that particular visualization. Verify this with the show interface iOS command. Verify this with the show interface iOS command. Also make sure that each sub interface on the router has the proper encapsulation type, right? So encapsulation is a IEEE standard. It is for trunk, so same approach is here also, I guess. But encapsulation type that we are going to adapt should be adapted in the all forms, switch interfaces and router sub interfaces. VLAN number, IP address, subnetwork mask configuration, those are the basics. So you should make sure that all the stuffs are streamlined. This can be done with the show interface or running config basic configurations command that you are going to use. Right? Confirm that the router is running an iOS release that support trunking. Some cases you may using routers which is not supporting for trunking. Actually, we check these things eventually because if router is supporting for trunking, only we can use the trunk configuration or trunk command we can find if it supports. So during the configuration, if we can do the configuration, then obvious it support the trunking. So some cases are implicitly addressed in such situations with the involvement of the routers. In the simulation environment, we can find whether those commands are available or not. If those are available, that means trunk feature is there, otherwise not. This can be verified with the show version command. So version helps you to understand whether it support for trunk or not. So let's move with the scenario 2. Scenario 2. VTP is not correctly propagating VLAN configuration changes. So you remember what are the VTP modes. So with that one, some forms are not transmitting the VLAN configuration, some forms are not. So by mistake, if you configure the things as the VLAN VTP clients, then eventually those configuration will not be appear in the neighboring switches, right? So make sure the switches are connected through the trunk link. VTP updates exchange only the trunk links. This can be verified with the show interface status command. So actually you better try with this, right? Arrange your own network and try to visualize this different situation, then you can understand, right? So make sure the VTP domain name is same in the all devices, right? If VTP domain name, hope you can remember the domain name. We configured it in the VTP lab. So domain name should be same to share the VLAN information, even not sharing the case. That means VTP transparent also belongs to the same domain if the name is correctly mentioned. The name is correctly mentioned, right? VTP updates are exchanged only between switches in the same VTP domain. That is the important part. If your domain is different, then VTP updates are not shared. So make sure that your VTP domain is same for the devices or intermediate device you want to configure into same thing. Show VTP status command will help you to identify that. Check VTP mode of the switch. If the switch is in the VTP transparent mode, it will not update the VLAN configuration dynamically. That is the feature of the VTP transparent mode, right? That thing also you already discussed. We already discussed and you already did the practical. You have idea about the transparent mode. It is not transferring any VLAN information with the others. So don't expect transparent mode to do so. Only switch in the VTP server and client mode update their VLAN configuration. So you know those things. We configure the VLAN in the server mode and those will be received by the client. Those will be received by the client. So that feature should be correctly implemented. It means you should not configure all the switches in the client mode. Then obviously you can't configure the VLANs. If you configure all in the server mode, and myself and you are server mode, and if you configure only yourself, then you expect me to take the configuration from you. මට ඔයාගෙන් ගන්නවා කියලා හිතාන හිටියට I will not take because I am also server. If both ends are server, then problematic. You have to configure both server switches, ETP server switches. But in case you are the server, I am the client, then obviously VLAN configuration will be shared. If using VTP password, the same password must be configured on all switches in the VTP domain. Right? VTP password should be same for all the devices. To clear the existing VTP password, use the no VTP password and command VLAN mode. Yeah, you can do that. Then scenario 3, drop packets and loops. Packets drop karana, loops ain karana. So use of the spanning tree protocol. Digital spanning tree route, IEEE spanning tree route, multiple switches. Actually, at the moment, you can't find any loops, no? Here loop is there, yeah, sorry. This part is introduced as the loop. We'll see. Spanning tree bridge use topology change notification BPDU packets, right? Topology changes are updated through the BPDUs to notify other bridges of a change in the spanning tree topology of the network, right? If there is any change, then that thing will be updated through the BPDU, right? So it will be notified to the other bridges as well. Second, it says bridge with the lowest identifier is the network become the root. Those things you are aware. Bridge priority is considered to finalize the root bridge. Then priority should be very low to assign it as the root. We just send these BPDUs anytime. We just send these BPDUs anytime. A port we just send these BPDUs anytime. A port makes transitions to O from the forwarding state as long as these are other ports in the same bridge group. Yeah, what it says, bridge sends BPDUs anytime, right? Bridge sends this BPDU anytime a port makes the transitions to or from the forwarding state, right? So there are transition from forwarding states, right? That means one time the port may be forwarding, other time port may be blocked. So not sure what is happening, right? So those information, those status are shared through the BPD. As long as there are other ports in the same bridge group, right? So if there is no any bridges in the group, then no matter. But if there are some other bridges or the switches, then obviously we need to recalculate and find the optimized bridge, optimized connections. So then BPD migrate towards the road bridge. That means these BPDUs migrate towards the road bridge. These can only one road bridge per bridge network. That thing is known. Only one road bridge is there in the network. Then finally, elections processes determine the road bridge. Yeah, election process, that means all the switches are competing to be at the road bridge. But finally, the election process is based on the priorities, MAC addresses, find out the best possible one for the road bridge. So the second statement, BPD migrate towards the road bridge. So I think it is just so whatever the information generated by non-root bridges will be forwarded to the root bridge. That might be the understand. Non-root bridge link generator and BPD use root bridge check කරාදමයි යන්න. Right? So because finally if there is a change, only that root bridge change happen, then happen first, then road bridge is the coordinator for that particular time, right? As far as the particular bridge is considered as a road bridge, then we have to send all the information to the road bridge, right? So that might be the understand with that second point. So the scenario 3 continues. Root determines the value for configuration message. Root determines values for configuration message in the BPDO, and then set the timer for the other bridges, right? So it is obvious the timers are set by the root bridge. So that part is clear. The second point, other designated bridges determine the shortest path to the root bridge are responsible for advertising BPDU to the bridge through the designated port. So we identify the different designated port, right? The designated port. So just find out the optimal way to reach the route. Optimal way to reach the route. Then thirdly, the bridge should have port in the blocking state if there is a physical loop. That's how we are going to avoid the loop. We introduce the block state for the different route. Then logically, administratively, they are down. Logically or administratively, they are down, not allowing to pass the message. Problem can arise in the internet network in which IEEE and DEC spanning tree algorithms are used by the bridge nodes. Yeah, okay. Then these problems are caused by the differences in the way that bridging nodes handle spanning tree BPDU packets or hello packets and the way that they handle the data. Yeah. When we combinedly use these different approaches to introduce the spanning tree, we focus about the IEEE approach so far. DEC also another approach. Then there can be different confusion. Then we'll see what we can do with that. In this scenario, switch A and switch B and switch C are running IEEE spanning tree algorithm. A, B, C running IEEE. D inadvertently configured to use the DEC spanning tree algorithms. Switch A claims to be IEEE root. Switch D claims to be DEC root. Then there are two algorithms. Two spanning trees are generated. So in the one spanning tree, contribute by switch ABC. The second one contribute only by the D only. So eventually the D will be the root in the second case with SDC, EDC, DEC spanning tree. So IEEE one used by 3 switches. So among those 3, one has been picked. Switch A. Switch B and switch C propagate root information on all the interface IEEE spanning tree protocol because they are not the root, they are just designated switches. However, switch D drops the IEEE spanning tree information. Right? Switch D is not considering IEEE related things, even though they are received by the switch because those are also frames. Those are also frames, but discard. Similarly, the other routers ignore the router D is claimed to be the root. Whatever the information is received from the router, this should be switched, right? Not the router. This should be switched. Switch D generates some BPDUs. Those are rejected by the other switches. Right? So obvious because those are two different protocols. One is IEEE, other one is the what's the DEC, no? Not familiar. Anyway, DEC, yeah. Actually, commonly used spanning tree protocol is IEEE 1. So you already familiar with that. The result is that is none of the bridges believing there is a loop. Okay. Right? Now, two things are running. As a result, none of the bridges believing there is a loop, and when broadcast packet is sent on the network, broadcast storms results over the entire internet. So we will go back to that diagram and visualize the situation as per now we have some understand about that diagram. This one is the IEEE spanning root. Then this one is the digital spanning tree root. This one. Then two things are, if this is root, if this is root for the digital spanning tree, then that is not counted by the IEEE, no? Then this is considered as a like this is not there. D එක නෑ වගේ තමයි IEEE වලට පේන්නේ. ඒතර IEEE හිතනවා මේක loop free topology එකක් කියලා. Digital spanning tree එකේ මේක consider කරන්නේ නැහැ. IEEE එක consider කරන්නේ නැහැ. එතකොට මෙතන switch එකක් නැහැ වගේ. So doesn't consider this there is a loop. There is a path. Eventually, logically, as they are using two different approaches, logically they can't see there is a loop. However, there is a loop in the actual situation. Only problem is they are using the two different spanning tree algorithms. when two different algorithms are used by mistake, right? You can't enable two different things. Then they try to maintain two different trees. One is not accepting, other one's root no. Eventually, although they try to introduce the spanning tree, they realize or they understand, they introduce the spanning tree protocol. It is not there in the actual way. Actually, it is not there because physically it is not there because some switches they have not considered. IEEE configure කරලා තියෙන එක අනිත් කට්ටිය consider කරන්නේ. එයාලා consider කරන එක IEEE consider කරන්නේ. That is the difference, right? Then broadcast packets is sent on the network. Broadcast storm result over the entire internet. Eventually, the broadcast storms are introduced because no one is agreed about the root bridge. This broadcast system will include the switch X and Y and below. Yeah, right. Expand through the network. Resolve this problem. Reconsider switch D for IEEE. So every switcher should be configured in with the same protocol. ඔක්කොටම apply වෙන්න same protocol එක නැත්නම් there are lots of confusion. Even in our administrative work also, the process should be very clear. That is the simple understand with this. The process has been introduced by the IEEE spanning tree protocol or the other one. If we pick the IEEE one, then every switches in the network should follow that one and introduce the spanning tree protocol appropriately. Otherwise, it just introduces confusions. Right? So, although configuration change is necessary, it might not sufficient to re-establish the connectivity. There will be a reconvergence delay as device exchange BPDOs and recompute the spanning tree for a network. So it takes some time to stabilize, even though you make change just now. So I think creating VLAN and assign ports, you already familiar with this. With that one, actually, we can finish. Yeah. Today, actually, we just extend what we discussed, like troubleshooting this stuff and things like that. The concepts are already discussed. So this is some sort of extension. With that understand, you should be able to attend with this sort of I would say management of the network accordingly to avoid the unnecessary traffic, right? Any question? Some questions are there still. We will address them with the next session, VTP, right? How router involved with that communication routing interface involvement. Other than that, 13 students are there. It's good. Relatively good, right? 15 were there. 15, 16 were there. Usually. Any question? So actually for this week, Thursday session, I will not take because I have to conduct online session, series of online session, contribute for the series of online session from Friday. I'm delivering a session also Friday for TVX sector. I think to prepare for that session Thursday evening, I might be little. Anyway, we have to get the demonstration of each and every lab from the individuals. For those are the assignments, right? Those are the assignments. So better try with the lab sheets, get ready to answer the questions and be familiar with the configuration, right? So troubleshooting part, many of the stuff, when you do the configuration properly, you can avoid those things, right? So otherwise, you just introduce the troubles and try to understand the concept. We discussed three scenarios. So for those three scenarios, you better introduce the network in that manner. Then you introduce that issue, then troubleshoot and understand what is actually happening. So that's it. Then we will finish for today. We conduct around 2 hours. Anyway, we finish with the fourth topic. Okay, thank you guys. So we will finish for today.